Hi guys, Mike here with you on the Sonics 413 channel with the long-awaited build-along video. This is a little bird we're going to be putting together. Before we get going, I just want to give a big shout out to all the guys that have been leaving comments on the videos. Richie and I love hearing from you guys, and keep doing it. Keep doing it. Now, this is not our usual action-packed flying video. We're going to be here a while doing this one, so you might want to just head out to the kitchen, grab a snack and a drink, and settle in for a building session. This is going to be more like hanging around the shop and building an airplane. And so I know there's a mix of skill levels out there in the viewing audience. We got some guys that are expert builders and could probably take a quick look at this thing and duplicate it, and then there's guys that have never built one. So to accommodate everybody, we're going to take a few side trips and diversions along the way and explain things that need explaining. So I apologize to the guys that for which some of these things might be a little elementary or whatever, but bear with us. You know, YouTube's got a feature you can click down there below the video and like speed it up to time and a half or whatever, and it'll sound like Alvin and the Chipmunks, but you can watch the video a lot quicker. By the way, probably you might want to watch the video once through before you actually do it, so that you get a good idea of what the process is like. Okay, there's the ship. It's not the absolute simplest thing that you could build, but it's got nice performance, and it's got some lines to it. It's kind of pretty. It's got about a 10-inch wingspan. It's about 8 inches long. It's got readily available components. We've got a 10 farad supercapacitor in there, a little slide switch so that you can charge it without the motor running, and then the motor itself is a little 6mm diameter by 15mm length. The one in this particular prototype plane is out of a toy model airplane, and it's only got a moderate power output. The one we're going to be building, and the one that we've got the link for the motor, is this upgraded 615 motor. It's a little higher output, and I think it'll make this airplane really perform well. So the one we're building on the bench starting now is going to be with this upgraded 615 motor. If you don't have one of those and you want it, and you can salvage one of these 615s out of a toy model, by all means, that'll work too. I'll explain the difference between them. This one, if you were to check with an ohm meter the internal resistance through the leads, you'd find that it's about 3 or 4 ohms. And if you check one of these hopped up motors, it's a lot less resistance than that. I think these in fact are about 1 ohm. And what that means, there's a lot fewer windings in there, and it's going to turn higher RPMs for a shorter duration. So the toy motors work. In a sense, they almost work too well, because they're less power output, but they seem to run forever. You have to really be careful how much charge you put on those. This one, on the other hand, will climb steeper and get back down. I still think with this combination, you're talking somewhere between 30 seconds and a minute anyway. Okay, so anything else you want to say about this? Yes, the wing and tail surfaces are made out of 1/16 inch material. It's from styrofoam picnic plates, and you know what I mean, these things. We'll talk about those a little bit later, but these are the really cheap, no-name brand foam plates, really thin, and sometimes they have a little warp in them, and that's okay too. We'll explain that later. We can utilize that in the under camber of our wing. If you've got ones that are perfectly flat, great, we'll use those too, because we're going to mount them onto a little curved root rib, and that's going to give it some under camber no matter what you start with. The tail boom is a square piece of 1/8 inch balsa wood. There's another little bit of balsa wood from the junk box that we build into a little switch plate. If you try to glue the tiny little switch right directly into the foam and then operate it, it'll tear right out. So we make a little wooden plate to put the switch on and then glue that wooden piece into the foam, and that gives it enough structural strength that you can operate it without breaking it off. The pylon and the fuselage are a little thicker material. If you've got 1/4 inch Depron, you can use that. If not, there's the supermarket meat trays. That's about 1/8 of an inch thick. You'll be able to take 2 laminations of that and come up with your 1/4 inch material, so don't worry about that. Let me think if there's anything else. Okay, so that takes care of actually the material for the airframe. Tools, you're going to need a good sharp X-Acto knife, a couple small pieces of wet or dry sandpaper, because we're going to be sanding wet. We want some 220 for pretty good material removal, and then a 600 grit or so to apply a few strokes and put a final finish on it. There's not much sanding to do on this airplane, but I'm going to show you how to sand with running water. It'll come in handy when you build airplanes that require the airfoil to be sanded into the wings. It really helps control that styrofoam dust. Okay, you're going to need a straight edge, a ruler, couple kinds of adhesive. Most of the construction is going to be tight bond, water soluble carpenter glue, or you could use Elmer's, either one. There's a couple of things we're going to want to have a little bit of 5-minute epoxy, so you need a bit of that. We're going to need the gear to do a couple little solder joints when we go to do electrical hookups, a really fine tipped soldering iron, little tiny bit of solder, couple pieces of tiny heat shrink tubing if you have it. If not, we can get by without it. Some of the stuff's optional. Then you need a few little straight pins, like dressmakers straight pins. You're going to need an empty cardboard cereal box. You're going to need a piece of string, a pen or a pencil, and a magic marker to apply the paint job. Quick word, at one of those side tracks while we're here, the Sharpies, or a lot of brands, it's great for putting a color scheme on it. Check the compatibility on a scrap piece of material before you try doing it. I wanted to make my MiG silver originally, and I started applying the silver marker, which it looks good on most materials, but on the foam it just started attacking it and eating right into the structure. So always check on a piece of scrap. But I've been using the Sharpie brand. It's great. It weighs nothing. Excuse me. It weighs nothing when you put it on there, and adds a lot to the looks of the plane. So I think that takes care of all the airframe and tools. Now let's talk about the running gear real quick. Everything that makes it run. I'll put links to these things down in the text description on Banggood. You can check them out. First is the 10 farad supercapacitor. This is pretty inexpensive. Let's see, it's about what is that, 10 millimeter diameter and about 25 millimeters long. It's got a designation dotted line going down one side adjacent to the short lead. That is the negative terminal. Those are supposedly minus signs, I guess. And that makes the other one, the long wire that's not marked, that's the positive lead. I understand that internally there's not much difference between the two different orientations. They'll actually work either way, but there's some slight differences that make it work better one way. And so that's the way we do it. Okay, so the short one here next to the markings is the negative, and the other one's the positive. Those are pretty amazing. Pretty amazing. They hold quite a bit of energy. All right, the motor is a 6 millimeter by 15. That shaft is looks like 0.8 millimeter, which is about 40 thousandths. And it fits this 50 millimeter propeller. Now, if you have a mismatch, if the shaft of a motor you're trying to use is bigger than the hole in the prop, easy enough, you just drill it up and put it together. If it's the other way around, sometimes you have a bigger propeller hole than you do motor shaft. In that case, slip a little piece of like very fine hookup wire insulation, that one that fits on there tightly, little length of it, it'll make like a bushing, and then measure what that is and drill the prop out to that, just about that size, just under, and then press that together. And if you get it to run straight and run true, a tiny little drop of super glue will keep it that way. So you can make anything fit anything, basically. In fact, this one is just such a case. Oh no. No, let me see. We'll figure that one out when we get there to the engine. And whoa, right there, that's where I knew something was going wrong. That propeller was supposed to fit that motor. Well, I shut the camera off and figured out what was going on. Everything's alright. That propeller I was trying to put on there, and it was too loose for the motor. I had drilled it out the other day. I was doing some test runs on the bench, and I had drilled it out and mounted it up to a bigger motor, a 7 millimeter. And so that's why it didn't fit. This is a brand new one, as delivered from Banggood. This is the Gem Fan 50 millimeter prop, and that goes on that 0.8 millimeter shaft just right. Oh, there we go. Now, let me show you something about these. When you put a propeller on one, you must support the back plate of that motor, that little white plastic plate. You've got to push from there. One way you might do it is put this on the bench and hold that back plate with your thumbnail, and then push it into the motor, into the propeller rather, like that. And then it's on there. You cannot do any damage pulling it off, but if you push it in without supporting the back plate, that's actually the brush plate of the motor. And now you can't see it on the video, I'm pretty sure, but it's got little metal tabs crimped over the plastic. That's the only thing holding it in. And it doesn't take much to, when you're pushing it, it'll blow that right out. It's blowing the guts right out the back of the motor. At that point, it's junk. It's unrepairable. Those brushes are so small you can't even really see them, and you'll never be able to put it back together. So when you're pressing a propeller onto one of these coreless motors, always support it from the back plate. Now, let's say you've built a model like the little micro Dakota here, and that is a 3D structure. The back of the motor is not accessible. What would I do there if I had to exchange a propeller? Well, of course, removing it is no problem. I can just pull it off. I'll never do any damage pulling, like I said. But putting it back on, what I do is, before I install it in a built-in hidden installation like that, I mix up a tiny batch of 5-minute epoxy, and I put a little tiny bit that covers the part where the back plate meets the can of the motor, and you can scratch it up with a little 400 grit first so that it'll stick to the can, and then a little 5-minute epoxy. Careful it doesn't get any place where it shouldn't be, but if you do that, it'll at least give you half a chance of being able to press on a propeller from the front when the back of the motor is inaccessible. Another thing about these motors and propellers is they each come in a left and a right rotation. So this one here, if we look at it, you can see that this is closer to the camera. It's the high edge, and it wants to turn this way. The other indication is this one, the hole for the motor shaft only comes in from one side, so you can't put it on backwards. Some have a hole coming from both sides, and you might have to identify the front and the back of the propeller. The back of the propeller, it has a cupped appearance. It's actually cupped here, and the front of the propeller is convex, has a little curve upwards. And this one here, again, the high end is here, means it's going to rotate this way. As we're looking at it, that is a standard rotation propeller. That's the way the prop turns on a nitro motor or whatever. That's called a standard rotation. If you have one that's pitched opposite, where the leading edge of the prop is over here, that's backwards rotation. Now, you can make either prop work with either motor because the motor leads are unmarked, and the motor doesn't really care which way you hook it up to the current. So we're going to, right now, cut this connector off. We're going to hook up a semi-charged capacitor and spin that for the moment and find out which is the correct wire to hook up to the positive to make the prop spin the right way. And we're going to mark the wires red and black. Okay, so let's do that. Going to untwist it a little bit. These come with little tiny connectors on them, and they're polarized in the sense that when you plug them into the intended installation, which is a little pocket quadcopter, they're polarized in that sense. They plug in correctly when you put them in the ready-to-fly quad. They're available as an upgrade motor for that quad, and we're not using the plugs, so we've got to figure out which is positive, which is negative, and depending on which prop we put on here, it's going to change that too. So I've cut that plug off, and I don't know how you guys like to strip this wire. I just grab a little bit between my fingernails there and pull it off. Seems to work okay. Now we're going to need something to run that on. Let's use our 10 farad cap. We're only going to charge it up to 1.5 volts with a single AA alkaline. Remember which one's the positive and negative. Dotted line, short lead, negative. That makes that one the positive. So let's take our wire, ordinary piece of hookup wire, and we'll just put that on the positive lead, okay? Make sure it doesn't touch the other one. And then we're going to hook that up to the positive of the penlight battery, the AA alkaline. So now we've got the two positives hooked together. Let's just take the negative and put it to the negative wire on the supercap. 1, 2, 3, 4, 5. That's all we need, because we just want to see that motor spin, see which direction it goes. Alright, get rid of that piece of wire. Now, here's our motor. Alright, we've got the prop on it. I'm just going to hold it like this and just, let's see, the long one's the positive. I'm going to put it there, and I'm just going to touch these other two for a moment and see which way it wants to spin. Let's see. That's backwards. That is backwards. So that means this one wants to be positive. Hook it up. Oh yeah, Now that's blowing a breeze back at me. Okay, so that means this one here is the positive. I won't lose track of that, but I'll get my red Sharpie out, and I'm going to just make the red end of that wire red. And if I want to get anal about it, I'll take and make the other one black. Alright, so now we've got our propeller mounted on the motor, and we've got our wires marked, so we don't have to run that again. We can just go ahead and install that in the plane and know that it's going to run the right way. Okay, so I think that's all about motors. You know about the lefties and the righties now, so that is that. Okay, that takes care of the motors pretty well, and we've got a couple other things to go, but I wanted to just take a minute to show you what came in from Banggood today. 8x20 motors, 7x20 motors, and what were those? 75mm propellers that come with these cute little spinners. Very nice. They had a quantity deal going on these that if I bought 8 of them, they're $1 a piece. I can't believe that. And by the way, whenever you order from those guys, when you go to your checkout, go to the shipping, and if you select their standard shipping option, it's always free. Even on these little cheapo items, you get them shipped for free. It's unbelievable. Okay. I wanted to still talk about the switch and the charging hookup. Switches are these little slide units. They're not ultra high quality, but they're only a few cents a piece. I'd recommend at least buy the bag of 20. They're I use them on these little models singly, and I've got a couple models that use the bigger 40 farad capacitor and twin 820 motors and whatnot. And what I do in the case of that, a little higher current use like that, I mount 2 of them side by side and wire them in parallel, and it's easy with your thumb to just operate them both at the same time, so you got double the current capacity. Link to those and all the other gear here is in the text description to the video. Alright, and one last thing is the charging hookup. I think I showed you earlier in the video, may have not, about how the charging adapter goes into the aircraft and touches the capacitor leads directly. Because it's got this little taper to it, I can just stick it in there until it's touching both of them at the same time, and it makes a good firm contact. Also, excuse me if I already mentioned it, I don't remember if I did, but it's polarized. The length of this part of the handle makes it impossible because of the location of the wing. I cannot put that in upside down. It has to go in this way, properly polarized. So on your designs, try to do the same thing. Okay, and also some airplanes, when you get into building stuff like this that's got a 3D body, the capacitor is mounted remotely from the charging jack, so you can't get contact to the capacitor leads directly. What I do in that case is take a little tiny piece of 1/16 balsa wood and put 2 little pieces of wire, like extra pieces of this stuff. When you cut it off, save the 2 little pieces of that. Put them side by side on a piece of balsa wood with a hole between it, and you can stick this right in between and touch both of those wires, and you make a tiny little plate like that with the 2 wires, and there's one mounted right there behind that hole. So I just put this in there, and there's my charge hookup. and the switch is mounted on a little plate of balsa wood as described earlier, so that it can be glued into the foam structure and has enough physical strength so that it can be operated without tearing it out. Okay, how do you make our standard charging jack here? Glad you asked. Here's a little sketch. You can kind of skip by it right now, but you're going to want to, after you finish your airplane, come back and build this. You can see it's representing exactly what I've got in my hand here. The blue part is 1/16 plywood. Dimensions as shown. At the tip it's 1/16 of an inch. It increases until it's 3/16 wide here. This width and length are not critical, but I recommend making it long enough so that you can have it be polarized when you put it in your plane. So you just cut that blue outline out of a piece of 1/16 balsa, or not balsa, 1/16 aircraft plywood, or could be 1/16 ABS plastic or something would work great too. Okay, now after you make that little wooden piece, get a piece of paper clip wire, or the kind of wire that's used as a lead on electrical components or something, and bend two pieces of it in the shape to follow where these green lines are here. And if you look at this, I don't know if you'll be able to see it, maybe not in this video, but you may get a little reflection off the top of that, and that's one piece of wire. It comes from it just follows the top edge and goes down the backbone here. That's this piece, okay? And then they're not touching at the tip, but then it's visible here along the edge, and it follows this edge down, and that's this piece, okay? And where they come down to the bottom, you solder on some wires, red and black. My convention is that I make this one here the positive on all my planes, so I can just use the one plug, fits everything I fly. So red and black, and the simplest way when you just get started, take the red and the black leads and go right out to 2 AA alkaline penlight batteries, size AA alkalines. 2 cells will give you just around 3 volts. Hook it up to the red and the black, positive and negative, and you don't need a meter, you don't need an indicator or anything. You can just stick it in the airplane and count off the seconds. 3 seconds would be like a nice little powered test glide, and then step it up to 5 seconds, 8 seconds, 10, whatever. Work your way up. Richie and I flew with nothing more than the connector and some AA cells for quite a while, until we got sick of buying the AA's, and then we started messing with building a charger. So I'm hoping this is actually legible. We'll hope it is. I'm going to put it right up here for 1 second. Hope you can read it. You can come back to that later. But someday you'll have that. Maybe we'll make that our standard size throughout the capacitor flying hobby, huh? You never know. Okay, now we really have finished looking at all the preliminaries. This little beauty is beckoning and awaiting. Just one more thing to do. Run out to the kitchen, slam the last half a box of Fruit Loops, and meet me back here with the empty cardboard box from that cereal. And we're going to make some wing templates and actually start building. Alright, let's measure and lay out for the wing template. We're going to take a piece of box top cardboard here, cereal box cardboard. And we're going to cut out a piece of that to make our template. And here's how we're going to lay it out. Oh, by the way, this has got to be about 11 or 12 inches long. 30 centimeters, let's say. Alright, we're going to take our straight edge and mark a line quite close to one edge here. And without being too precise, we'll find the center point for that. Should be right about there. We're going to mark that point. Okay. And now we're going to take and measure a few points here. First of all, at 3/4 of an inch from that line, there's 3/4 of an inch. For those of you guys working in SI units, that's going to be 19 millimeters. Let's see, there's our 3/4 of an inch. Precisely, well, pretty close to 19 millimeters. Okay, and then the next point we're going to measure is 5 inches, which is 127 millimeters. There's 5 inches. There's 5 inches. Alright. And then we're going to take our straight edge and connect those points with lines. Piece of cake so far. If you're following along, we're both going to end up with the same exact airplane here if we measure carefully, right? Alright, now if you've got a draftsman's triangle, great, get it out. If not, just anything that's got a good square corner on it like that. CD case from my old band, Out of Order. We're going to line up with I'll do it where you can see it here. We're going to line up with that line. Let's see. Okay. Draw that. Close enough. Alright. Now, the next step, we're going to measure 1 3/4 inches back from that center line. I guess I'll use this one. 1 3/4 inch. Again, if you're working metric, that's going to be 44 millimeters. 1 3/4. 1 3/4. Let me know if you try measuring in millimeters and inches and you get a different result in the flight performance. Let me know. Because that'll be interesting. Okay. Now, right where we marked these at 1 3/4 from the center line, we're going to just draw a little straight line to bring it down to that first 1 3/4 of an inch away. Alright. Now, it would really be super if you had a compass, but if you don't, we're going to improvise anyway. What we're going to do here is, well, if you have a compass, you're going to do without the improvisation. Little piece of cardboard here. I marked 2 points exactly 7 inches apart. Again, if you're working the SI units, that's 178 millimeters. And I'm going to take a dressmaker's straight pin, put it right through at one mark, and then 7 inches away at the other mark, I'm going to put a little hole there, and through which I can fit the tip of a ballpoint pen. So Now I've got a very accurate compass set at 7 inches. So what I'm going to do here is the pin is going to be on this second line here, and the writing pen is going to be right there. So now I'm just going to hold the little sharp point in, and I'm going to swing an arc here. Alright. Then swapping around, again putting the ballpoint pen there, lining it up with this point, which I can do better. Well, let's see. I can actually see through there and line it up. There it is. And again, holding the sharp point of that pin into the base, and I'm going to swing this arc. Alright. Put that aside. And now, reach in your pocket, find the largest coin you have in your pocket change. There it is, United States 5-cent piece. That'll work. Whatever you've got. Put it up into that point there. Okay. And hold it down and draw that arc right there. Okay. Put away the money. If Richie's around, he'll grab it. Okay, and then this should be symmetrical, but because we're going to use it for left and right, we want it to be the same going both ways. So we'll go ahead and mark right here, and imagining that this is the top view of the right wing, this is then the front. So we'll go ahead and mark our template like this. Arrow facing front, and this is the right wing. Okay. That's it. That's the template. And the reason we're making it out of this cardboard here, first of all, it's easy to lay it out, but also we can save it and duplicate and make another airplane if you want. Carefully, as carefully as possible. This isn't exactly going to the moon, if you know what I mean. There's the original first line we started with. We're going to cut that straight. Later when we go to glue the left and right halves together, they're going to have a little curve to them, so we're going to end up sanding a little bit here, but we'll worry about that later. Okay, so we've got our wing shape pattern here, and what we're going to do is prepare to lay it out on our foam plates, which need just a word about the foam plates first. These really need to be the super thin ones, the cheap bargain basement ones that you would never use at a picnic because they just will not hold a decent amount of food. These are so flimsy, but that's exactly what makes them suitable for a little model like what we want to make. These check out to be right at 0.62, 0.63, so they're right at 1/16 of an inch. For the SI guys, that's about 1.5 millimeters. So definitely really thin. You don't want to buy the high quality picnic plates these are the ones you want. Now, if you look at them, you can see that there's some warping going on there, and I've got some marks on the plate so that when the mark is pointing right at you, the warpage, the axis of the warp is pointing right at you also. And if we flip it over, you see what I mean there? Can you see that? The dish shape is lined up with the camera right when those marks are passing each other, like that. And you can see there's like a swoop to it here. Okay, so we want to take enough time to carefully eyeball the plates until you can determine where that axis is, and mark it both sides. Okay, and then you can see that this is the dished or concave side, and when we look at this side, it's the convex or bowed outward side, and we've got marks on it like that. Okay, it's worth taking your time to get that accurate, because that curvature or that bow is actually going to be our wing undercamber, and when we glue the two wing halves together, it's going to get locked in there. Now, I have been thinking about it, and it makes sense to me that if you were to, of course, line it up like this with the axis of the wing along with the axis of curvature, that's going to give you a nice even undercamber from root to tip. Should be the same. But if we start skewing this axis of the wing with the axis of curvature, what that'll actually do is, if we go this way, it's going to give us washout in this wing tip, and if we go this way, it gives us wash in on the wing tip. So that's just some food for thought. We're going to go ahead and do it straight. I've taken and marked arrows there to point us in the right direction. We're going to find a good flat area on the bottom of the plate there, and of course this is the convex side of the surface, and now I'm going to mark that. And the reason we made the wing the shape it is, such a low aspect ratio, is because that's about the only decent part you can cut out of that plate. We're basically using it all. You can see it just bowed up there when I released it. Now we're going to take and transfer our mark right there. That shows us that that's the top of the wing facing forwards that way. Now, we'll take this off. This whole stack was bowed exactly the same way. There's that mark, there's that one. Now, if we do this, we're going to make another right wing. So what we want to do is make a left wing, and this mark is now going to be over here. Line up that axis with the two marks down the center line of the wing, and then go ahead and mark it up. I think I figured out that these are, I believe, a little under 25 square inches of wing area. Now, we don't want to forget our little mark. So, if we put them that way together, that's our full wing with the dots facing front, and we're looking at the top of the wing. I'll go ahead and cut these out and be right back with you. Okay, we've got our wing blanks cut out, and aren't they lovely? With a little dihedral in them, the projected wingspan is 10 inches. And the only thing left to do on them now is, afterwards, we're going to stack sand those and sand the outline to make them match perfectly. We're going to put them aside for now though, because we're going to also have a little bit of sanding to do on the tail surfaces, and we want to do it all at the same time. So we'll put that aside and let's get those tail surfaces built. Again, we've got our little piece of tag board, and we're going to make a template on that. Same routine as we did on the wing templates. We're going to actually draw it out, and I think it's going to work out all right. We're going to start with just a vertical line like so. Oops, and I was going to say, and a horizontal line. We want to make sure it's perpendicular, don't we? Alright. Takes a little while to lay out these templates, but if you afterwards write on the template what it is and save it, it takes a while to make the template, but you can make another set of wings in about 1 minute. Alright, so we've got two intersecting perpendicular lines. We're going to measure up 2 inches from the center, make a little mark there. For you metric guys, 50.8 millimeters. Then at that height we're going to go over 1/4 inch. In metric speak, that's about 6.5 millimeters, and we're going to put a little point right there where that intersection is. Now we're going to draw a line from the origin here, the intersection, up through that point. Piece of cake. Yeah, there's no blueprints for this airplane, but we're all going to end up with exactly the same thing. That's pretty cool. Alright, 1.5 inches back on the horizontal axis. We're going to make a mark. 1.5 inches. How many millimeters is that? Oh, about 38. Alright, and then from that point we're going to drop down 1/2 inch. That's 13 millimeters. And we're going to make a little mark right there. So we're 1/2 inch down, and we are, what is that, 1.5 inches over from the vertical. And we've got a point plotted. Now, if you remember in part 1 how we improvised that compass, we're going to do the same thing here. In fact, the same one cut down. There's 2 points which are 3.5 inches apart. That's 89 millimeters. One of them is going to have a straight pin, and the other's got a little hole where I can stick my ballpoint pen. So, remember that point right there that we laid out in the middle there? We're going to put the pin right there, the pivot. Okay. Then, while we're holding that, we put the writing implement here and swing an arc right through that whole quadrant there. That's pretty easy. Then we're going to take any coin of your choice, put it right up into that point there, and then draw an arc that's tangent to those 2 lines. Boom. There's our piece. And let me show you what we're going to do with that. First of all, go ahead and carefully and accurately cut it out. You know, I was wondering how I would get everybody to build the same model, and I'm thinking how to email blueprints back and forth and everything, and then I thought, no, we are just going to draw that stuff. Now, that is our vertical stabilizer, or more popularly known as a rudder, I guess. now let's take this line here, put that right on it, trace around, flip it over, I can find the spot, there it is, and we're going to trace around that one. Ooh, it moved. It moved a little harder. Alright, we re-achieved alignment. Continue the outline. There it is. So now that is our horizontal surface, and that's going to be our vertical. So there's our tail group. I must say, kind of stylish. Cut this out. And once again, you've already got these templates. It took longer to make the templates than to make the parts. You can blast out a fleet of these things. Get about 6 different colors of magic markers, so you can do a different paint job on each one. Tell them apart. I guarantee if you make 6, every time I've made multiples of free flight models, toss gliders or whatever, they all, if you make 6, there's 3 of them that fly real good. There's 2 of them that fly pretty good, and there's 1 of them that, even though you built it the same, you don't know what is the matter with it. Never could trim it out. All right, well there's our templates. Super. Now, also throwing back to part 1, do you remember how we eyeballed the plates to find the axis of the warp in them? Well, if you saved an extra one that you marked, you're way ahead of the game. But if not, go back, rewind the video, and take another plate and mark it up like this, same way we did for the wings. So what we're going to do here is, there's our axis that we talked about, the warp axis, and we're going to put the stabilizer with the long axis parallel with that. Okay, and we're going to put some little marks on that center line, and that's going to help us when we affix it to the fuselage. Alright, so there's our, that's going to be our horizontal. Now we'll take our pattern for the vertical, which is half of that, align it that way, piece of cake. Okay, there's our tail group, and our templates are in safekeeping in the safe deposit box. Alright, I'm going to cut these out, and we'll be back in a moment. Stick around. Alright, there we have the tail surfaces all cut out. Looking pretty good. I like the lines of that. There's not much to say about cutting them out other than use a good sharp X-Acto blade. The way you tell when a blade is getting a little dull is it starts snagging on points in the styrofoam. So I use a little whetstone, a little ultra fine granite stone there, and every few cuts I swipe the blade over that a couple of times, and it puts the edge right back in it. Alright, again, we don't want to do our sanding right away, so let's take all our sheet foam parts and put them aside and wait for the sanding. Next step is going to be out of some of this meat tray material. Richie loves to build planes out of this. There's limitations how much flat area you can get out of it. Right now we're just looking for a little piece. This stuff comes in different colors, by the way. This black one here, I cut small circles out of it, put a hole through it with a little piece of like nylon tubing, and then spin it on the electric drill and use a Dremel tool spinning there, and sand away at the rotating little wheel circle blank and make wheels out of them, and they come out pretty good. You can see right there they've actually got little plastic bushings in them. They spin beautifully, they spin true, and they look like rubber. The black part of that, you're looking at the bare plastic that's been sanded. Looks just like rubber. And I'll tell you what, they're so light. When I was making these, I dropped one, and instead of falling to the floor, honest to God, it floated down to the floor. It fluttered back and forth like a leaf. It was crazy. So you can add a little scale detail like that. We're not doing that right now. We need part. Although you could use the black. We're going to make a little blank here that we're going to use to as the basis of our fuselage. So you can make it out of the white material or the black or whatever you've got. We need a little rectangular template. I'm not going to take the time to measure that out with you. All I can tell you, it's 7/8 of an inch wide. That's 22 millimeters. The length is 4 inches, 102 millimeters. So check out your styrofoam meat tray. This stuff is a little over 1/8 of an inch thick, by the way. And I see a nice piece right there that I can get a perfect piece out of that size, and another one right here. So we're going to laminate 2 rectangular pieces together to make our fuselage blank. And this has got a different feel to it than that picnic plate material. By the way, when you're working with this foam stuff, you've got to recalibrate your sense of touch and be very delicate with it. It's like if you were a truck driver, a truck mechanic, and you were going to go work on your motorcycle, you would have to dial back the muscles a little bit. Okay, let's cut these out. That's a good sharp blade, but I'm still not trying to go all the way through at once. 2 or 3 cuts, you can feel what it wants to do. And I can feel that that's cutting very smoothly, leaving a nice smooth edge. Nice material. The other thing to keep in mind is to hold that knife oriented vertically so you don't end up with a lopsided edge. Oops. There it is. Alright, there's our 2 pieces. And by laminating these, we're going to end up with a little bit stronger piece. We're going to end up with a reference line going down the middle, which is going to be handy when we mount up the wing. And it's still basically going to be a profile fuselage, so the capacitor is going to sit right in there. We'll cut a slot out for it later, and it'll just about fit in there flush. We'll be able to hold it in with a little piece of clear tape. I'm going to try to keep everything real simple. Now, we're going to want to glue these together. To get a good glue joint, 2 steps. First thing that's already been done is, of course, if these used to have meat in them, which they all did, is give them a really good wash in the sink with hot dish water, dish soap, good hot rinse, let them dry out so that they're absolutely clean. And even if you get them brand new from the meat department at the store, give them a good wash, because I have a feeling there's some kind of food grade mold release or something on these, either food grade silicone or something from the manufacturing process, and I think it interferes with the glue bond. So these have been washed. We're going to take now a piece of this is 220 grit, and on the surfaces that are going to be glued, not going to do any serious sanding. We're just going to lightly wipe that surface with the 200, and that's going to give us a little bit of tooth to the surface there, and let the glue really set up good. We're going to use original Tight Bond yellow glue. It's real cheap and it works. Sets up pretty good, pretty quick. I'll take some. Tiny bit there. Put just enough and spread it out so you actually just lightly wet the surface everywhere. And do the same thing here. Already tacking up. Alright, so there it is. We're going to go ahead and align them as well as we can. Squeeze them together a little bit, and then what I'll do is I'll put these on a nice flat surface with a little bit of weight on them. Hopefully they don't move. That little bit of liquid glue in between them can make them slide. You want to check that they don't. There's that. And we'll use our little, I'll tell you what, here we go. Look at that. Okay, I can feel the edges aligned here. We're going to let it dry with my little whetstone sitting on it. And while that's drying, we're going to take a break, but in the meantime, one other thing we're going to need for this project is a small length of, well, some kind of a stick. I'm using a 1/8 inch square balsa wood, medium balsa wood stick out of the scrap box. Let's see what that is. It's 128 thousandths, so it's 3 thousandths over an 1/8 of an inch. So 1/8 of an inch. And the metric reading, we're at about let's see, that's 3.3 millimeters. 3.3. Now, I've had some of the subscribers mention that they can't get balsa wood where they live. If that's the case, you could use a little bit smaller cross section of any kind of straight grained wood. You could split a piece of bamboo down to about, oh, 1.5 millimeters or 2 millimeters either square or round. But either way, we're going to need a stick, nice straight piece. We don't need this whole length, but this is a little over 6 inches. That's plenty. We're going to cut that down. So find a 6-inch piece of some kind of straight, fairly lightweight stick. If you want to get fancy, carbon fiber will impress your friends. Okay, we're going to let that glue set up, and when we come back, what are we going to be doing? Oh, we'll start making a couple other pieces we need to do the wing assembly, and then we're going to sand those flying surfaces. So stick around. Hope you're keeping up with it and sticking with the project here. I think we're going to end up with some cool planes. See ya.